Hi, I'm Yasin Samlali, and in this video, I'll be presenting my recommendation report for the new Marble Divider in the Marble Machine X. The Marble Machine X, primarily made by Martin Mullen with the help from his Discord community, is a device that uses nothing but marbles to play music. One of the most crucial components of this device is the Marble Divider, which takes a sequence of marbles and divides them into separate channels through feeding tubes. The current version has the marbles slide along a track and drop into a tube, with the marbles rolling over the tube once it fills up. The main issue with this design is that if a marble sticks out too far or too little, it will block the marbles behind it, causing a clog in the flow of marbles to subsequent tubes. Since the plan is to go on a tour with this machine, this chance of failure is unacceptable, and so Mullen set out to improve this design. In this presentation, I will determine which one among the Rosero design, the height modules, and the Andrew design is the better solution to this problem. To accomplish this, I examined the design's ability to overcome the height issue I explained previously, the ease of manufacturing and adjusting the design, and whether or not the marbles can consistently roll down the track using the design. Using these three criteria, my main findings were that the Rosero design was far and away the best in terms of simplicity and effort, though it could sometimes be unreliable depending on the angle of the axis. The height modules, on the other hand, were too time intensive to manufacture and install, and had too many parts. Finally, the Android design was similar to the height modules, but was slightly easier to install since it could be adjusted instead of having to completely replace the part each time we want to make an adjustment. The conclusion was that the Rosero design was the best among the three. Using this design, there is no need to do any adjustments on the marble machine when the depth of a tube changes. Additionally, it is just one part with few components, meaning that the manufacturing process is also much faster than the other designs. However, tests show that it could be inconsistent at actually transporting marbles depending on the angle of the axis, and therefore further improvements are recommended. In the following sections, I will provide details on the methods used in the experiments, the results obtained, the conclusions drawn from those results, as well as a recommendation on how to proceed. To establish which design is best, the first thing that was considered was the ability to deal with different marble heights. In the current design, the marbles roll on a track and fall into a tube. When that tube is full, the marbles will then roll over it into the next tube, and so on until the end is reached. The problem with this implementation is that if a marble sticks up too far, it can block the marbles behind it, preventing the marbles from flowing properly. This was considered by evaluating each design and seeing if it can overcome or even bypass the issue, with bypassing the issue being preferred due to reducing possible points of failure. Another aspect is the ease of manufacturing and calibrating each part. An easier manufacturing process will reduce the time, effort, and cost necessary to create parts, and the ease of calibration will save time when on tour, where the machine will likely have to be readjusted after transport. The former was evaluated by counting the number of parts in the prototype, while the latter examined the steps required to install each design, choosing the one that is least time intensive. In this case, the design that moved on to the final testing phase is the Rosero design. Tests were conducted to determine the design's ability to actually transport marbles in the Marble Machine X. First, a prototype was built out of wood. Rolled up pieces of cardboard were inserted at different depths into the tubes to simulate different heights in the top marble. For testing, the prototype was set up at a 4.5-degree angle, the same angle as in the current system. Marbles are then rolled down until they either get stuck or reach the end. If the marbles get stuck, the angle is adjusted along the axis, which helps them roll more easily. The angle along the length is not changed because changing that angle in the Marble Machine X would require a lot of work, while changing the tilt of the axis is trivial. If the design is determined to be capable of consistently transporting marbles from one end to the other, it is accepted. Otherwise, it is rejected. The results of the marble height test were that all three designs were satisfactory. The height modules and the Andrew design both dealt with the problem by being able to adjust the height of the top marble. The height modules did this by swapping each piece out until the top marble was flush, and the Andrew design adjusted the height of the top marble by sliding a part in and out. The Rosero design, on the other hand, completely bypassed the issue by being height independent. The marbles pass over the track and roll sideways into the tubes, instead of falling down, meaning that the top marble can be at any height and it won't interfere with the rolling marbles. The number of parts was then considered, and the Rosero design came out on top for this as well, since it is made of just one track, meaning that the number of parts required is significantly reduced. As for the time it takes to actually adjust the heights on the machine, the height modules took the longest, requiring each one to be removed and replaced with the appropriate height. The Android design was better in that respect, with each piece being individually adjustable. Finally, the Rosero design required no adjustment at all as a result of being height independent. From these results, the Rosero design was chosen to take part in the future tests. To test the rolling ability of the Rosero design, the axis angle was first set to 24 degrees. In this configuration, the marbles started getting stuck after just a few tubes. The angle was then set to 18 degrees, which made the marbles go further, almost to the end. The angle was decreased again. This time, the marbles could reach the end of the track, and the design was accepted. The conclusion reached was that the Rosero design is the better design based on the criteria. The other designs solve the height problem, while the Rosero design bypasses it entirely, making it an issue that doesn't even need to be considered anymore. Additionally, it has the fewest parts and does not need adjustment. In the end, I recommend that the Rosero design be used in the Marble Machine X. It has proven to be superior to the other designs in terms of simplicity and ease of use, and has been shown to work well when well adjusted. Additionally, the small number of parts required eliminates potential points of failure, reducing the risk of failure for the machine as a whole. The only downside is that the range of the axis angle required to make it work is rather small, so it would be good to find a way to improve this in another prototype before finalizing the design.